Yeah, hello everybody. So in this video, we are going to study activity 1.8. So activity 1.7 about electrolysis of water. So that video has been made and how to do this activity practically and show to your students also that I have already done the video. Please watch the video and you can use the same materials, simple materials which are available to do this experiment. Okay, fine. Now let us see activity 1.8. So in this activity 1.8, so we gonna study about endothermic reactions. As I have already explained you in the previous videos that exothermic reactions. Exothermic means what? Exothermic in any chemical reaction during a chemical reaction, if heat is released, okay, if heat is liberated, okay, in any chemical reaction, if heat comes out or heat is liberated, in that reactions are called exothermic reactions. Now, from activity 1.8 onwards, we study about endothermic reactions. Okay, endothermic reaction means what? In any chemical reaction, if heat is absorbed or if heat is absorbed and chemical reaction takes place. So, such type of reactions are known as endothermic reactions. So, here in activity 1.8, let us see. So, what is happening? What are the activities about? Take 2 grams of silver chloride. Okay, so what is the formula of silver chloride? It is already given, AgCl. Okay, so Ag is a silver and Ag means silver and Cl chloride. So silver chloride, chlorine, in a china dish. Okay, here we took, and what is he saying? This 2 grams actually. The color of the, he is asking what is the color of silver chloride. Okay, the color of the silver chloride will be white in color. Okay, the color is white. So if you take that silver chloride and if you put it under the sun, okay, under the sun for some time, so what happens is under the sunlight, so heat absorbed by this silver chloride, and what happens after some time? So after some time, we see that the color of the silver chloride, what is the color of the silver chloride? White. So the color becomes, okay, the color changes into gray color. Okay, you will find that it changes into gray color. So why does this happen? Because the silver chloride absorb the heat. Heat is absorbed. So such type of reaction is known as endothermic reaction. Okay, so silver chloride. So what has happened? And this is also an example of. Tell me, it is also an example of decomposition reaction. Okay, decomposition. So suppose you can remember this hint like AB gives rise to AB gives rise to A plus B. Okay, the compound silver chloride, after absorbing the sunlight, after absorbing the heat, when heat energy is produced or given, so it is again divided into silver solid and chlorine gas. Okay, fine. Now let us go to the next page. So then, what is the okay? So benefit. This is very important question which can be asked in MCQs. Silver bromide. So here, silver chloride. What happens? The silver chloride changes into gray color after absorbing the heat. Similarly, not only silver chloride, even silver bromide also behaves in the same way. It also absorbs the heat and changes into gray color. Now, what is the benefit of this? What is the use of this silver chloride and silver bromide? Okay, the main important, is these above chemical reactions are used in black and white photography. This is very important. So, which type of reactions are used in black and white photography, or which chemicals are used? Okay, in black and white photography, silver bromide and silver chloride. Okay, silver chloride. Okay, this is what you should remember. So this can be asked for MCQs in for 1 mark. Okay, now fine. So here, if you read this, what is he saying? What form of energy is causing this decomposition reaction? Tell me what form. So heat energy. And what is happening? Whether it is coming out or going inside, it is absorbing. So this is an example of endothermic reaction. Okay, so in any chemical reaction which heat energy is absorbed or energy is absorbed are known as endothermic reactions. Okay, fine, understood. So the next one, carry out the following activity. So what is he saying? Take 2 grams of barium hydroxide. Okay, take 2 grams of barium hydroxide. What is the formula of barium hydroxide? Ba, I'm writing here. Okay, BaOH2. Okay, he's saying take 2 grams of barium hydroxide and add, what is he saying? 1 gram of ammonium chloride. Add what? 1 gram of ammonium chloride. So the formula will be ammonium chloride. I'm writing the chemical reaction. Okay, chemical equation here, NH4 ammonium chloride, and mix with the help of glass rod. So what happens, like, if you do this activity, you'll feel that heat is absorbed. Okay, so it is also, and test tube with your palm, and he's saying that chloride, and mix them. Okay, and mix these solutions. So what happens here? It takes the heat energy. Okay, plus heat. Then what happens is, what will you get? You will, if you do this activity and if you touch the bottom, he's saying the bottom of the test tube, you will feel warmness. Okay, so if you write the chemical equation for this, so barium hydroxide, so when and if you add ammonium chloride solution, okay, heat in the and okay, so heat is absorbed, and then it gives us barium chloride. Okay, barium chloride plus ammonia. Okay, barium chloride plus ammonia and water. So this is what the final result. Okay, now I think it is not balanced, so we need to balance it. Okay, so ammonia, hydrogen, three, four. Okay, so put two here. Okay, and then here, yeah, here you need to put two, and the water also four, eight. Yeah, so one more two in front of hydrogen. Okay, now this equation is balanced. Okay, fine, right. Now, so he's asking, is it? Do you feel any change in the temperature? Yeah, I feel the change in temperature. So why this is happening? Because here we are adding both. So we are giving the heat energy. So in this is an example of endothermic reaction. So this activity, barium hydroxide plus so ammonium chloride. So is an example of endothermic reaction. Or you can write this also, silver bromide. If you exposed to sunlight, it gives silver plus bromine gas. Okay, all these are the examples of endothermic reaction. So this can be asked even in your board exam. So this is very, very important. And next one, so next question is, a solution of substance X is used for whitewashing. So already we have learned. So which solution it is? So that is calcium oxide, or it is also known as what? Quicklime. Okay, so I'll write the answer here. Calcium oxide, calcium oxide, or it is also known as quicklime, and the formula is C, calcium oxide. Okay, and then so that the substance X is calcium oxide, and he's asking to write the name the substance, writes his formula. So formula also have written, and substance is calcium oxide, which we used for whitewashing. Okay, and then write the chemical reaction of reaction X in the above water. Okay, with water. Okay, this is very, very important. So he's saying that write the reaction of the substance X named. Okay, so he's asking to write the reaction. So I'll write CaO, calcium oxide. It is in which state? Already it is there. We have studied solid state plus, and you need to add water to it. Okay, add water H2O. Okay, and water is in liquid state. So you'll be getting calcium hydroxide. Okay, calcium hydroxide. So it is actually subscript. You need to, okay, I'll write here calcium hydroxide, and the state, it is in which state? It is in aqueous state. Okay, because it is dissolved in water and it produces the heat. So this is an example of exothermic reaction. So I'll write two here. Okay, even these two also under subscript. Okay, So this calcium hydroxide. So name the reaction. Okay, this is a reaction. CaO plus H2O gives rise to CaOH. Okay, twice. Okay, CaOH2 and above with the water. So this is called as slaked lime. We call it as slaked lime. Okay, the reaction which we have already studied. Okay, now why is the amount of gas collected in one of the test tubes in activity 1.7? So what is activity 1.7? Next question. It is electrolysis of water. So he's saying that why the amount of gas collected is double the amount of other. Name this gas. So which gas it is? So which is the activity? Tell me which activity. The activity is electrolysis of water. Electrolysis of water. Okay, electrolysis of water. And what are the gases collected? Tell me the gases which are collected. You watch the video also, please. Okay, gases are collected at where? Tell me. Collected at anode and another gas collected at the cathode. Okay, so now he's asking why one gas is double the other. Okay, suppose if you write the reaction, chemical reaction. Okay, so what are we taking? We are taking water in it, right? So H2O. The formula is H2O. Okay, I'll write uh, H2O. So what happens? So when H2O under, okay, H2O, when you give electricity, under the passage of electricity, when you pass electricity, so this is the answer for second one, okay? Second answer, this question. So let me write, you'll get hydrogen plus oxygen, okay? Hydrogen plus oxygen gas, they are collected. Okay, so which gas? So at cathode, at anode, okay, at anode, oxygen gas is collected, and at cathode, hydrogen gas. Now he's asking. So we observe that hydrogen gas will be more. Okay, so H2O gives rise to hydrogen plus oxygen. Now, if you observe here, is it balanced? No, it is not balanced. So hydrogen is two, here two, right side, but oxygen are two atoms, here only one. So So 2 here. Now how many hydrogen atoms have become? So hydrogen 4. So it is 2 only. So then put one more 2 here. And oxygen 2, 2 balance. Now if you observe, the amount of hydrogen atoms have been increased when you pass the electricity. Okay, so 4 atoms of hydrogen and 2 atoms of oxygen. So that is the reason why the amount of hydrogen gas will be more at the cathode. So this is what you should write the answer. You should write the answer for the second one. This is also an important question which may be asked during even in your board exam. Okay. Now let us see the next activity is displacement reaction. Okay, displacement reaction. So again, a simple trick you can remember: A plus BC gives rise to AC plus B. Okay, AC plus B. Now here what happens? B is displaced. Displaced means change the place, and it joined with A. And what happened? Like sorry, C is displaced and joined with the A, and B was removed from the compound. So this is an example of displacement reaction. Okay, so displacement, there are four types of reactions. Okay, so this is a displacement, and after that we study about double displacement. So here, if you observe, if you consider A as one atom, B as another atom, C as another atom, total how many atoms are there? Three atoms. Okay, and if you observe how many atoms displaced, only C, that is one. So if only one single atom displaced in any chemical reaction, that is called single displacement reaction. So it is also known as single displacement reaction. So he is asking, let us do activity 1.9. So this activity 1.9, I have already made the experiment, okay, and I'll upload it in the I'll give in the description. So please watch the video so that you can understand it better. Okay, so activity 1.9 I have already explained you. Now if you observe here, so what are we taking in this activity? We are taking iron. So iron is in solid state, and we are adding copper sulfate. Okay, the copper sulfate into the test tube. Okay, so copper sulfate, if you add, it will become copper sulfate solution. Okay, that is the reason we are writing it as aqueous. and then it gives iron sulfate FeSO4 plus copper. So if I write the same with a hint like A plus B in AB form, ABC form, A plus BC gives rise to AC plus B. Okay, so what happened? B is displayed. So we can consider that B is a less reactive element or less reactive element. So here before that, before going to study, we should know the reactivity series. Okay. So reactivity series of metals. We study in third chapter. Okay. So I'll tell you here. So reactivity series of metals. So first, I'll start with high reactivity metals to low reactivity metals. First one is potassium, next sodium, then next calcium, then magnesium, and then aluminium. Next one is aluminium, and then after aluminium, zinc. Okay, after zinc, iron. After iron, lead, plumbum, also called a plumbum, and then hydrogen. Then hydrogen is not a metal, it's a gas. Okay, so there are some exemptions. Okay, then copper after that mercury. Okay, after that mercury silver, after silver gold, after gold platinum. Okay, so these are the reactivity series of metals. Okay, first if you see, so I have written from top to bottom means high reactivity metal, so high to low, so high to low reactivity of series of metals. Now, if you observe, we have two metals here. One is iron. Okay, so iron. Where is the iron? Iron is here, and another metal, copper. Okay, sulfur and oxygen are gases. So copper is here. Now, if you observe, which is a more reactive when you compare with iron and copper, we see that iron is more reactive. So what it will do is, see, iron displaced copper. Why it has displaced copper? Because copper is a less reactive metal. So it displaced copper and iron occupied sulfur and oxygen, or iron is reacting with sulfur and oxygen. So and it forms iron sulfate. Similarly, another example is also given here, zinc plus copper sulfate. So if you see here, where is zinc? Zinc is here and copper is here. So from these two, which is more reactive? Zinc is more reactive. So what zinc will do? Zinc displace this copper again. So zinc displaced copper and zinc is reacting with sulfur and oxygen. So it has formed the sulfur zinc sulfate. Next one is lead. Okay, lead and copper. Now tell me which is the more reactive again? Lead is more reactive. Okay, so lead displays copper again, and it formed lead chloride. So these are the some more examples of single displacement reactions. Okay, so we should know about reactivity series of metals. Okay, so the most reactive is potassium, sodium, calcium, magnesium. Okay, aluminium, zinc, iron, lead, hydrogen, copper. Okay, copper, mercury, silver, gold, and platinum. Okay, so this is about single displacement reaction, and this activity 1.9 I have already made a video. Please watch the video. Okay, and then after that another experiment, double displacement reaction. Okay, so here you can remember in this way, in ABCD form, AB plus CD. Okay, so let us have AB is a compound, CD is a compound. Okay, and A is a atom, B atom, C atom, D atom. So now, if you write like this, AC plus BD. So what happened here? So C displaced and reacting with A, B displaced and reacting with D. So this is called. So how many atoms are being displaced? How many elements? Okay, two. So if two or more elements or two or more atoms get displaced in any chemical reaction, that is called as double displacement reaction. Okay. So this activity also I have made the video. So you may watch the video which been uploaded in the description. Okay. So here take about. So what is this activity? Take about 3 ml of sodium sulfate solution. Okay. Sodium sulfate. So what is the formula? Na2SO4. Very, very important. Okay, you need to underline each and every formula and you need to practice it. And what will be the color of this sodium sulfate salt? Tell me. The color will be white color. Okay, so here double in this reaction, it is a precipitate reaction. It is also known as precipitate reaction. Okay, fine. Now, and he's saying that in another test tube, take 3 ml of barium chloride. Okay, barium, this is the chemical formula. What will be the color of barium chloride? Again, barium chloride also will be in white color. Okay, barium chloride also will be in white color. And then, so if you do this activity, so what will happen is, here if you observe sodium, okay, sodium and sulfur oxygen and barium chloride. So barium displaced sodium, okay, barium displaced sodium, and then, and after that barium formed barium sulfate and chlorine, okay, and sodium chloride salt, sodium chloride, and Na is reacting with chlorine, and it formed the sodium chloride, so barium sulfate. So how many elements got displaced here? Two. So this is an example of double displacement reaction. Okay, suppose if it is asked in exam that give some more example, you can write. So you can write one more example. I'll give you here. So silver nitrate, AgNO3, silver nitrate. Okay, it is a substrate actually. Okay, uh, which will be dissolved in water, aqueous, plus if you add salt, sodium chloride, salt. Okay, salt, then you will get silver chloride, AgCl. Okay, silver chloride. Here you will find this silver chloride precipitate forms. Okay, okay, silver chloride plus sodium nitrate, NO3. Okay, NO3. So this is what you'll get, and here it is a precipitate reaction. So I'll put an arrow down. So this is also even in this equation also, if you see, so two elements got displaced. So another example of double displacement reaction, and precipitate is formed. So we put an arrow down. Okay. So this is all about activity 1.10 double displacement reaction, and then he is asking recall activity 1.2. Okay, where you have mixed the solution lead 2 nitrate and potassium iodide. And what is the color of precipitate formed? So okay, you see the color will be yellow. That also I had made the video. Please watch the videos. Okay, watch the video, then you will understand, and try to answer the questions which are given in this page. Okay, and next one, oxidation and reduction reaction. Okay, so oxidation reduction, I have made a simple video, very simple video. Okay, a trick to remember oxidation and reduction. What is oxidation, what is reduction, by using AR Rahman. Okay, that trick I have made, and that video also uploaded. You please watch that video. So here if you observe this activity, I'll just explain you. He's saying that take copper powder. What is the color of the copper? Tell me. The copper powder will be in the brown color. Okay, and then and take it in a china dish, 1 gram of copper powder, and heat it. What do you observe? When you heat this copper powder, brown color changes into black color. Okay, it changes into black color. Okay, and then he's saying if you pass the hydrogen gas, so now let us see that, let us assume that this is a copper powder which turned into black color after heating. Now he's saying that now pass hydrogen gas through it. Okay, pass hydrogen gas to it. Okay, and then what happens? Then the color of the, then color changes again, it come back to the same color, brown color. Okay, so here we are giving heat energy, absorbing it, absorb heat energy. So again, this is an example of endothermic reaction. So these are called reverse reactions. Reverse reactions. Okay, so copper, when you heat it, so oxygen is merged. Under the presence of oxygen, it forms copper oxide. What is the color? Black color. And then the same copper oxide, if you pass hydrogen gas to it, okay, and then again it come back, again it form copper and plus water also. Okay, water moisture. So this is a reversible reactions. Okay, so this is a about activity 1.2.5. Okay, and here few equations are given. So he's asking to find what is oxidation, what is reduction. Okay, what is oxidation? Tell me. Oxidation is nothing but gaining of oxygen. So here if you observe, hydrogen do not have oxygen, so it gained oxygen, so it is called oxidation. So copper has oxygen, so it lost the oxygen, So it is called reduction. So what is oxidation? I'll write here. So oxidation means gain of oxygen or lose of hydrogen. This is called oxidation reaction, lose of hydrogen. Then reduction reaction. What is reduction reaction? Gain of gain of hydrogen. Okay, gain of hydrogen or lose of oxygen. So this is called reduction reaction. Okay. So he is asking to find out which is which is oxidation and which is a reduction. So you need to write here. Okay. Try this. Okay. Any doubt if you have, you may put the query in the description box. Okay. And last topic. So with this chapter will be concluded. And now he's asking in reaction 1.31, carbon is oxidized. Means carbon gain the oxygen, and zinc it is reduced to zinc. So it is called as reduction reaction. Okay. So this is the definition he has given here. Okay. So simple trick also I made, oxidation reduction using AR Rahman. Okay. Please watch that video. You will understand it better. Now, recall. Again, we recall activity 1.1. What is activity 1.1? Activity 1.1 is nothing but burning of a magnesium ribbon. This activity also I made. I uploaded the video. Please watch it. Okay. So what happened? Magnesium being oxidized or reduced in this reaction is asking. When you are heating it, is it oxidizing or reducing? So that also is asking. So you try to answer this question, okay, after watching the video. Fine. Now, have you observed the effects of oxidation reactions in daily life? Okay. Have you observed the effects of oxidation reactions in the daily life? Oxidation means what? Gaining of oxygen, gaining of water moisture. So what happens? So if any substance gain oxygen, it will get corrosion, okay, or rancidity. So rancidity and corrosion, what is the difference? See, corrosion means suppose if you exposed any metal objects to the any metal object, suppose iron nail, if it is exposed to the moisture, to the atmosphere, what happens? It changes into its color becomes dull. It changes into brown color. So because a layer of oxide, okay, because the copper, if you it reacts with oxygen, it forms a copper oxide. So that is called corrosion. Okay. Suppose if silver oxide, okay. So all these are the effects of oxidation in the daily life. So why the iron nail gets the color changed? Because of that only. Okay. Suppose if copper reacted, the color it changes into light green color. Okay. So all why this been happened? Because they are exposed to the oxygen, they are getting oxidized. Okay. So what are the effects of those oxidation? If they get oxidized, their strength become weak. You can easily break the iron nail. The strength of the metal becomes weak. Okay. So these are the effects of oxidation. So one is corrosion. Corrosion means what? Corrosion means forming a layer on the above the surface of the metal. Okay, when they expose to the moisture or oxygen. Next, what about rancidity? Rancidity means change in smell and taste. Okay, so rancidity means change in smell or the taste. This is the about rancidity. So what happens when can we see a smell change in taste? Suppose any oily item. Suppose let us take chips. Chips. Suppose if you take chips or kurkure, when if you expose it in an open air, what happened? It gives a smell changes. Smell changes and taste also changes. Taste also changes. So that is called rancidity. So then what will you do? How will you preserve those substances which which are made up of oil and exposed to oxygen to save them from smell changes and taste changes. You need to use the tight containers. Okay, we will use the tight containers. Like what we do, suppose if you are preserving the pickles, okay, pickles, we keep them in a tight containers, right? And also chips and or kurkure, whatever, which are made up of the potato chips are oily packets. So what we do, so if you I think you might have seen the chips packet is filled with some air, right, some gas. So that gas is called nitrogen. So which gas they use? They use nitrogen gas. Why? Otherwise, what will happen? The chips get oxidized, and the chips, like become very, the smell changes states, it won't be crispy. Okay, it won't be crispy. So to protect those oily items which are you made up of oil, and they will be preserved in a tight containers, as well as, and they will be preserved under the nitrogen gas. So very very important topic. So how to protect the oily food items? So one is storing them in a tight containers, put materials in a tight containers, and also by filling it them with the nitrogen gas. Why? To prevent them to react with oxygen, getting oxidized. So this is all about rancidity. Okay. So these question and answers. Now I think this chapter is completed. Only few question and answers are given in this page, and briefly explain you why did the color of the copper sulfate changes? Okay, copper changes when iron nail is dipped into it. Okay, write down the answer. Okay, please note down the answer. Because so iron is more reactive element. Okay, reactive metal, more reactive than what? Than copper. Okay, iron is more reactive than copper. Okay, I'm writing the answers here. This is the first answer. Iron is more reactive than copper. And what happened then? It displaces copper and displaces it from where? From copper oxide, copper, from copper sulfate. Okay, so that is the reason the color changes, copper sulfate. Okay, and what happened as a result? You may write down the answer. As a result, copper is copper is deposited where? Deposited, and ferrous ferrous sulfate is formed. Okay, ferrous sulfate is formed, and what is the color? Which is in light green color. Understood? I hope you understood. Light green color. Okay, so that is why the color been changes, and also you may write the color also. Okay, you should write the color as well. And what was the color compared to previous color, compared to dark blue color of copper sulfate? Okay, this will be the answer for first one. And also give an example of double displacement reaction other than given in activity 1.1.10. So he's asking to write, give a double displacement reaction. Any other example? Okay. So there are many examples that he's asking that instead of writing which is given in 1.10. Okay, sodium sulfate. He's asking to write another double displacement reaction. So which one you may write? You may write this chemical reaction. Okay, iron. Okay, plus copper. So this I'm writing. Okay. Sorry, this is not for second one. This is for this one. Okay, the first one only. Chemical reaction. I'm chemical equation. I'm writing copper sulfate. Okay, 4 is a subscript. Okay, so FeSO4 plus copper. Okay, this reaction is already given. And second answer is asking to write the equation for double displacement reaction. You may write lead nitrate. I think you remember it. Okay, lead nitrate NO3 which is in solid state, plus potassium iodide. Okay, I am writing the balanced equation, okay, which I have already explained and given even in the in your textbook as well. Okay, what it forms? It forms lead iodide. Okay, lead iodide which is in solid state. Okay, plus potassium nitrate. Okay, aqueous lead iodide which is in aqueous state. Okay, so I'll just correct it here. So what will be the correction? They are the subscript. Okay, here you should write 3 here and 2 also small. Okay, this 2 also here and 3 here. This is the example. This is the answer for second one. Okay, and now third one. So he's asking identify the substances that are oxidized and which are reduced. So here just we need to identify. See here sodium gained oxygen. So we write it at, we just put an arrow and we mention here oxidation. Okay, and here if you observe copper lost the oxygen, right? It lose the oxygen. So we'll put an arrow and we write here reduction. Okay, so it is reduction. So this is all about this chapter. Okay, I hope you all have understood. If any doubts if you have, you put please put comment in the comment box, and the answers for this whole chapter I'll upload another video. So with that we'll conclude this chapter. Okay, thank you everybody, and I hope you have understood. So very important that um, you should read each and every chapter, every sentence, and underline and make your own notes. Okay, and whatever the chemical equations and reactions which has been given in this chapter, you need to practice them more, and then you'll definitely get out of marks from this chapter in the board exams. Okay, thank you everyone.